Hello, everyone. Welcome to our another discussion for the topic standard normal distribution. So, in this topic, you will be able to describe the standard curve in terms of classroom assessment and locate the location of a given row scores in standard curve. So, are the characteristic of a perfect normal curve. So, as discussed already in our face-to-face discussions, um, the performance of the class can be described as a normal curve, skewed to the left or skewed to the right distribution. For a normal curve distribution, we have this following characteristic. First, the mean, the median, and the mode is at the center of the curve. 68% of it is one standard deviation away from the mean. 95% falls two standard deviations away from the mean. 99% scores fall within three standard deviation away from the mean. The two tails of the curve get closer and closer to zero without reaching zero. So to give a clear picture of those characteristics, so this is the standard normal curve. So as you can see, there is 50% above the average, and there is also 50% below the average. So the z-score is computed by this formula. You have the row score minus the mean divided by the standard deviation. So that means to say that the z-scores that we have here are just the location of each row score if we're going to compare it within the class average and the standard deviation. So that's why it's also important that we only use standard normal distribution for a normally distributed data. Okay, so as you can see here, this is the 34%. So here is the 60% of the distribution, 64 rather. Sorry, it's 68%. Here is the 95%. And three standard deviation away is what we called the 99% of the distribution. Okay, and it goes closer and closer to zero as it goes away with the standard deviation -3 or +3. Now, when it comes to computing z-scores, as I've mentioned already, z-score will tell us the location of each row score in relation to our average and to our standard deviation. So that's why when it comes to assessment and learning, standard normal distribution is one way to use in a norm reference type of data. Again, when we talk about norm reference, that means to say we are just comparing a certain learner when it comes to the class performance. Okay. However, if we talk about criterion reference type of assessment, that means that we are comparing the learner performance on the standard or on the standard that is created, for example, in our learning objective. All right. So I hope that that one is clear. We're only using normal distribution data to describe the performance of a learner or even number of learners when it comes to the class performance. Okay, that's why it is called norm reference. Now, let's say we have this example here. So a normally distributed class averages 75 with a standard deviation of 5. So there is two problems. First is determine Mark's location in the normal curve if he scored 67. And if there are 50 students, determine the number of students who scored above Mark. So as you can see here, we're just describing the performance of Mark and when it comes to in relation to the class performance. Okay, so let's compute first for the z-score. The z-score will just be z is equivalent to the row score, which is here our row score, by the way, is 67. Our mean, obviously stated in the problem, is 75. And our standard deviation is 5. So that gives us 67 minus 75 divided by 5. And of course, that gives us negative 8 divided by 5. And negative 8 divided by 5, that is negative 1.6. Okay, so now if we're going to locate it, obviously 67 is below the average, which is 75, but it gives us more picture or a clear picture where is the location of Mark's score when it comes to in relation to the normal distribution. So if this one is the curve, let's say this is 0 here, this is negative 1, negative 2, and negative 3. Clearly, we're gonna locate Mark's score between negative 1 to negative 2. So that would be negative 1.6. All right. So now the second question is, if there are 50 students, we're going to determine the number of students who scored above Mark. So before determining the number of students who scored above Mark, it's important to know what is the probability or the location or that area under this or which Mark score is located. So in this example, by the way, this is our table for let this be our what we call this uniform table of standard normal distribution. You could have a different reference in the internet or in the Google search, but let's just use this for uniformity because this one gives us a clear picture from negative curve to positive curve. Some tables would actually give us only the 0.50 average or only the negative or the positive average. So I have uploaded this one in our Google Classroom and please utilize it for uniformity. All right, so now the second question we have in the problem is how many students scored above Mark? Again, we have to locate the probability of that negative 1.6 before we can answer the question. So the first question now is, what is the percentage on that Mark's scored location? So this is negative 1.6, this is negative 2, and negative 3. So here would be, that means to say above, so it is clearly on the right side or going to the positive side of the curve. So we just need to look on the table, and since this is negative value, let's just look for negative 1.6. So that's the value there. And there's no point values anymore, only negative 1.6. So we're gonna choose 0, 0. Okay, so let's just look for that, and that gives us negative 0.0548. So that's the area. So from this negative area going to that negative 1.6, that means that is negative 0.0548, right? But that's not what we are concerned of, because we need to look for the values above, the percentage above Mark score. So that means to say, since we know that the area of the curve is equivalent to 100%, then we can just say, or equivalent to 1, so then we can just say the score of mark, or that value of 67, is equivalent to 1 minus 0.0548. Okay, go ahead and use your calculator to solve for that. That could be 67, or you can also use the negative 1.6. Greater than negative 1.6, that would be 0.94. Again, 1.1 minus 0.0548. That gives us 0.9452. Okay, so that means to say this area here from negative 1.6 down to the right part of the curve is 0.9452. And that would also mean that those are the past percentage. So if you multiply that by 100%, we have 94.52%. So hence in the class, there are 94.52% who scored above mark score, which is the score of 67. So now since the real question is how many or the number of learners, then we can just go back to 0.94. So that means 50 times 0.9452. So, or in your calculator, the one that we have earlier, we just have to multiply that by 50%. Or sorry, 50 learners. That gives us 47.26. 47.26, or approximately 47 students scored above mark. Scored above mark performance. All right. So that's all about standard normal distribution. And I hope that you have learned in this lesson so that you will be able to answer our learning exercises at the same time during our prelim examination. Thank you so much.